Hey everyone. So today's an exciting day. We are going to dive into the quadratic formula. Now, I want to just recap what we've done so far. This is kind of the second half of our quadratics unit. The first half we dealt with quadratic functions, and then we moved into quadratic equations. And when we're solving quadratic equations, normally what we're doing is we're bringing everything over to one side and we're setting it equal to 0. From there, we have looked at solving by graphing technology. So we've put it into y1 and we've calculated the roots. We've looked at solving by factoring using the zero product principle. And then in our last lesson, we looked at if it's in vertex form or it's easy to put into vertex form, we could then complete the square by putting it into vertex form, and then we end up square rooting and solving that way. Okay. Now we're going to take a look at the final item, which is called the quadratic formula. And to do it, I want to take a few minutes and derive it with you, which I think is super exciting. You may not think is super exciting, but I want to see if you can follow it. And remember, the good thing about the video is if you don't follow it, rewind it, do it again, okay? One of the reasons I want you guys to have these resources is to have the chance to go over things again. Okay, I think that's really important. It helps our brain process things when we get to hear it multiple times. Okay, so what we're going to do is we're going to take a random quadratic. Okay, and the way we're going to make it random is I'm just going to put letters in for the coefficients. Okay, so we're going to use ax squared plus bx plus c equals 0. And we are going to solve that together by completing the square. Okay, so how do I do that? Well, first of all, I want you to think, I'm just trying to get some ink on here. Okay, I want you to think if we were gonna try and complete the square, we would want to get rid of that c from there so that we could start working on getting a perfect square trinomial on the left. Okay, right now I don't know that that's a perfect square trinomial, so I want to force it to be a perfect square trinomial. So I'm going to subtract c from both sides. That's fairly easy. So that's why I ended up with this negative c here. Okay. The other thing we always wanted to do to create a perfect square trinomial is we didn't want a coefficient on the x squared, and we ended up dividing that coefficient from both the x squared term and the x term, right? So if I was to do that right now, I'd essentially divide by a, and divide by a, and I'm a very bad mouse drawer. Okay, so I divide everything by a, that's going to leave me with x squared here. It's going to leave me with b over ax and equals negative c over a. Okay, nothing nefarious yet. This is good. Okay, everybody with me? Yay. Now, we want to make this guy our perfect square trinomial. So I need to add a number to that. And remember how we do that is we half the coefficient and we square it. So half of b over a would be b over 2a. Remember we talked before, when we want to cut a fraction in half, either we half the numerator or we double the denominator, okay? So half of b over a is b over 2a. And then I need to square that. Well, I square the top, square the bottom. So I've got b on the top, that'd be b squared. Don't be squared. B squared. And then on the bottom, I had 2a. When I square that, that would be 4a squared. Okay, so my magic number right now would be b squared over 4a squared. And I want to add that to both sides so that I maintain equality. Okay, so, sorry, I lost my mouse. Okay, so I've added b squared over 4a squared to both sides. Okay, now, let's think about this fella for a second. I want to add those together. So in order to add those together, I need a common denominator. My common denominator will be 4a squared, but that means that negative c over a there, I'm going to have to multiply that by 4a over 4a to get that common denominator. Okay, so when I do that, I just did it as a sidebar over here. So I took my negative c over a, and I multiplied it by 4a over 4a. That's going to give me negative 4ac over 4a squared. Okay, so now I have a common denominator, and so this can equal b squared minus 4ac all over 4a squared, okay? Now, on the other side, I've got this cute little perfect square trinomial. I know that that's going to factor into a binomial squared. Well, remember, the first term will be x. The last term will be the square root of this last term here, right? Well, the square root of that would be b over 2a, right? I just square root the top, square root the bottom. And then the sign in the middle is the sign in the middle. We've done that with other lessons. Okay, so that factors into x plus b over 2a all squared. And then it equals on the right side, I've got that b squared minus 4ac all over 4a squared that I was just talking about. Okay, okay, so what's the next step? Well, then if I'm trying to get x all by itself, I need to square root both sides now, right? So when I square root both sides, on the left, I'm going to be left with x plus b over 2a. On the right, I'm going to be left with plus or minus the square root of that whole thing. And we need to kind of unpack what that whole thing is going to look like. Well, we know already that when I have a square root of a fraction like this, I can square root the top and I can square root the bottom. The reason I'm bringing that up is because right now I can square root the bottom easily, right? The square root of 4a squared is 2a. So I'm going to rewrite that as plus or minus the root of b squared minus 4ac all over 2a, so that my root is not on the top and bottom. Now it's just on the top because I was able to take the square root of the bottom. Okay. Now the other thing I'm going to need to do is if I want x by itself, I need to get rid of this fella. I don't think my head is going to be in the way here, but just in case, I will shut myself off for a second just to make sure you see that. Okay. What I see when I'm recording and what it shows up as when it's exported as a video are not always the same thing. So I just want to make sure I don't cover important things as I go. Okay, so now I'm also going to subtract b over 2a from both sides. Okay, and that's going to leave me with x equals, so I've got that negative b over 2a. And then this is just like I told you, I have plus or minus the square root of b squared minus 4ac all over 2a. But now what I want you to notice is I have a common denominator on the right side. They both are over 2a, which means I can just add those numerators together. Okay, I can make it be one fraction. And so I'm left with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That, my friends, is the quadratic formula. Okay, I don't want you to miss what happened. If you're watching this for the very first time, your head may have exploded. You know, you may be like, why did anybody decide to put letters into math? I get all of that. I want you to go through this a couple of times so that you feel better about it, okay? But once you've gone through it a couple of times, I want you to really hear this statement. What we did is we started with any old trinomial and we solved it to its roots. So this is saying x will equal this with those a, b's, and c's coming from this a, this b, and this c, which means now we can take any trinomial. We know what a will be, we know what b will be, and we know what c will be, and we can just plug it into this formula. Now, some of you may look at that and say, oh my dear Hill, why didn't you teach us this at the beginning? Well, there's a lot of reasons I didn't teach you this at the beginning. Number one, it's not actually the best method, okay? And I'm saying that from experience. You have to hear me out because you guys in the next couple of examples are going to look at this and say, no, this is way easier. By my experience, kids screw up the quadratic formula way more than they screw up factoring. Okay, if you can factor something, that's the better method. Go and do the factoring. That's always your top priority. You want to ask yourself, can I factor this? Okay, if it's not easily factorable, well, then you may want to have a conversation. Is it already sort of in vertex form? Because if it's already in vertex form, why multiply it out so that you can use the quadratic formula, right? Or maybe completing the square is a better job for you because maybe it just is a more succinct way of working with it because you've got numbers in front of you instead of letters, okay? But then this is also another tool that's available to you when all the other tools may not be working for you for a particular question, okay? Now, on a test, we will force you to use different methods because part of the curriculum is that you understand how to use every method. So there will be times where we say solve by an algebraic method of your choice. There will be times where we say solve by an algebraic method, but you can't use the quadratic formula. Okay, so that would be either you have to factor or you have to complete the square. And then there will be times where we say use the quadratic formula. Okay. All right, so this is the quadratic formula. By the way, that's not something you have to memorize. That would be given to you on a formula sheet. Okay, so everybody take a deep breath. You don't have to memorize it. It's all good. So this essentially gives us a formula where completing the square has already been completed. We did it with that base quadratic. So we can now plug the values of A, B, and C in to determine the roots. Okay, so let's practice this a couple of times with the examples that you see in your book. The great thing about the quadratic formula is that you can always find the solution with this method, though it may require some more work or simplification. And we'll talk about some of that simplification as we go here in a minute. Do not default to the quadratic formula, okay? Try the other methods you already know first, and I just had already kind of given you that sermon. Okay, algebraically solve the following using the quadratic formula. So when you are asked to use a quadratic formula, when you are asked to use any formula, the very first thing you should do in your communication, write the formula out, okay? Now, I know that my A value is 3, my B value is -5, and my C value is 2, okay? Always take into account the signs that are in front of those coefficients. They're part of the coefficients, okay? So don't look at this and say, oh, I'm subtracting 5. In this context, you want to look at that and say, oh, my coefficient on X, that B value is -5, okay? So now if I'm going to go plug all this in, this says -B. So that'll be -5, okay? So that'll just be 5. B squared, well, -5 all squared is 25. So I'm just going to write 25 in there right away. Okay, -4 times 3 times 2. A is 3, C is 2, and then that'll be over 2 times 3. Okay, so I've just plugged in all the values for A, B, and C, and I did that squaring at the same time. Be careful, don't get lazy in your calculator and just type in -5 squared, right? Because if you type -5 squared into your calculator like this, -5 squared, your calculator is going to tell you that's -25, and your calculator is not lying. You didn't put it in right, okay? If you're going to use the negative there, you have to tell your calculator it's this, so that your calculator understands to use the negative inside with the square, okay? Personally, in a 20-1 class, I would want you to realize that the negative squared is going to be a positive anyway. So I would want you to just think that B squared, just think of it as 5 squared, okay? Okay, get rid of that. And so now the next step I did was I figured out what number essentially was underneath the square root. So I did this 25 minus 4 times 3 times 2, okay? 4 times 3 times 2 is 24. 25 minus 24 is 1. So right now I'm looking at 5 plus or minus the square root of 1 all over 6. Okay. All right. So here's my two answers. First of all, I know the square root of 1 is 1. So this becomes 5 plus 1 all over 6 and 5 minus 1 all over 6. So those are my two values. Okay, so I'm going to split it into those two values. X equals 5 plus 1 over 6. 5 plus 1 is 6. 6 over 6 is 1. So that's where the 1 comes from. Or X equals 5 minus 1 over 6. 5 minus 1 is 4. 4 over 6 reduces to 2 over 3. So I have two solutions from using the quadratic formula. So I write it in solution set. X equals the set of 2 over 3, comma 1. Okay. Awesome. All right, let's try another one. 4x squared minus 7x plus 1. Okay, so again, I'm going to write my formula down. I know that my A value is 4, my B value is -7, and my C value is 1. So I'm just going to plug that in for A, B, and C. Again, b here, it says negative b, so that'd be a negative 7, and those two negatives gave me the positive 7 there. Negative 7 all squared is 49, minus 4 times 4 times 1, all over 2 times 4. So just some common mistakes that I see kids make sure the line here goes all the way over, okay? Sometimes I see kids do a line like right here, and then they mess up because they don't realize that that negative b is still part of the same fraction, okay? Make sure your square root symbol goes all the way to the end of the c, okay? These sound like little things, but if you don't write it properly, you're not communicating what you think you're communicating, and that's never a good thing, okay? It's never good in relationships, and it's never good in math. Okay, so now I want this guy to be a whole number, so I'm gonna go 49 minus 16, essentially. 49 minus 16 is 33. So I have 7 plus or minus root 33 all over 8. And then there's nothing really I can simplify that with. That is gonna be my answer, okay? And that's a perfectly acceptable way to answer. I've shown my two answers. I've got the plus and I've got the minus. The radical is simplified. Everything's been reduced as much as possible. I'm good to go. This is my answer, okay? Now, again, I want to make sure you understand what you just did, okay? So permit me 10 seconds to explain what just happened. If I was to graph this and I was to calculate the roots, my graphing calculator would give me 2 decimal approximations, okay? If you type 7 plus root 33 all over 8 into your calculator and get that decimal approximation, that's going to match one of the decimal approximations, actually the one on the right, if you want to get super specific. It'll match that decimal approximation that your graphing calculator gave you. And then if you go 7 minus root 33 all over 8, that will match the other one, okay? You are finding where this graph hits the x-axis, where the x-intercepts are, where the zeros are, where the solutions are, okay? You are finding that, but the powerful thing is this is finding it for you in exact value, where your graphing calculator is only giving you a decimal approximation, okay? Okay, let's try this one. 2x squared plus 6x plus 1 equals 0. 2x squared plus 6x plus 1 equals 0. So again, I'm going to write my formula down. My a value is 2. My b value is 6. My c value is 1. So I plug in all of that. I've got negative 2 plus or minus 36, that's b squared, minus 4 times 2 times 1, all over 2 over 2. Sorry, 2 times 2, not 2 over 2 there. Sorry. Okay, again, I'm working underneath the square root first. I want that to be one number. So 36 minus 8, essentially. That's going to give me negative 6 plus or minus the root of 28 all over 4. Now, we go back to 10c. We say to ourselves, hey, the root of 28 can be written as the root of 4 times the root of 7. So I can simplify that radical, right? Because the root of 4 is 2. So root of 28 could actually be written as 2 root 7, okay? If the last 5 seconds of this video just tore a hole in your head, you want to go back to my videos of 10c and just review some of the radical videos, okay? There would have been 2 or 3 videos on simplifying radicals and writing as entire radicals. So you might just want to review that just as a refresher, okay? Okay, so that's going to be 2 root 7. And so now the last thing I can do here is I see a 6, a 2, and a 4. I can actually reduce that. All of those terms can be divided by 2. So I'm going to reduce that down to a negative 3 plus or minus root 7 all over 2. This is the way you need to have answered the question, okay? So your answers are always one big, beautiful fraction, and it needs to be as simplified and as reduced as possible, okay? Again, remember, the question won't say answer an exact value. If the question doesn't give rounding instructions, that means you have to answer an exact value, okay? So we'd be looking for an answer like I've shown you here. Don't you dare give me a decimal approximation for this. It will not go well, okay? All right, so 3x squared plus x minus 5 equals 0. Again, I'm writing down my formula. My a value is 3, my b value is 1, and my c value is negative 5. So I plug all of that in. Okay, underneath the square root, I've got 1. Essentially, negative 4 times 3 is negative 12 times negative 5 is positive 60. So I've got 1 plus 60, that'll be 61. So I've got negative 1 plus or minus root 61 over 6. Root 61 doesn't simplify, so that's the best I can do. That is simplest form that I can give for the answer. Okay. All right, you guys are doing awesome. If you're not feeling awesome, it's going to be awesome. You just got to practice, okay? You got to give yourself the processing time in Math 20-1. It's so important. There's so much more to process in Math 20-1 than there was in 10C, okay? So if things feel overwhelming at first, that is okay. Keep going, keep pushing through, keep trying to make the connections that we need you to make, okay? That's how you have success in this course. Okay, so now I've got 6x squared minus 8x minus 3 equals 0. Again, I'm going to write my formula down. My a value is 6. My b value is negative 8. My c value is negative 3. So I'm going to plug all of those things in. And the first thing I'm going to do here is figure out what's underneath the square root. I want that to be one number. So, you know, you can even just grab your calculator right now and go 64 minus 4 times 6 times negative 3. Okay, that is okay to do. That's going to give you 136. So right now I'm looking at 8 plus or minus the root of 136 over 12. So I'm looking at, hey, can I simplify 136? I know for sure that's divisible by 4. I might try 16. I'll find out that 16 didn't work, but I might have tried it. And so I'm looking at, it was 4 times 34 is 136. So the 4 comes out and becomes a 2. That's where 8 plus or minus 2 root 34 all over 12 is coming from. Okay. Now, when I look at these three terms, they can all be reduced by 2. So I will go ahead and do that. That way my answer is in simplest form. And that simplest form would be 4 plus or minus root 34 all over 6. Okay, 4 plus or minus root 34 all over 6. So again, remember, that means there are two solutions. There are two x-intercepts. One of them is occurring at 4 plus root 34 all over 6. The other is occurring at 4 minus root 34 all over 6. Okay. All right, good. Let's try this guy then. 3x squared plus 12x minus 8 equals 0. We're going to write down my formula. My a value is 3, my b value is 12, my c value is negative 8. Plug all that good stuff in. Okay. The next thing I want to do is I want to get what's underneath the square root to be one number. So 144 minus 4 times 3 times negative 8. I also know that that's going to be 6. Okay, so that gives me negative 12 plus or minus root of 240 all over 6. Okay, root of 240 is divisible by 16 here. It's 16 times 15. No, I don't know that off the top of my head. I just quickly did it on a calculator. That's off camera. I shouldn't have told you that. I should have just pretended I could do those things in my head. Okay, so it's 16 times 15. And that means the 16 will come out and be root 4. Okay, so I'm looking at negative 12 plus or minus 4 root 15 all over 6. Now, when I look at those three numbers, everything's divisible by 2. So I'll reduce it. I'll simplify it to x equals negative 6 plus or minus 2 root 15 all over 3. Okay. Important little point here that I was just thinking about while we went through this, and it involves your communication. Please notice for every line I'm giving you, it says x equals, okay? You have to talk in complete sentences. Don't just say equals this, equals this, equals this. What equals that? It's x that equals that, okay? So make sure you're communicating nice and clear. Okay, so now we're gonna shift, sort of. This is very connected to the quadratic formula. But there is something else about the quadratic formula called the discriminant. If you discriminate against somebody, you essentially put them kind of outside into their own group. You kind of set them apart, okay? Usually in the English language, you set them apart for a bad reason. But the word discriminate really means to set apart, okay? So in math, there is a piece of the quadratic formula that we can set apart, and it tells us a little bit of information about our graph all by itself, okay? So the discriminant helps us determine the nature of the roots. Now, I talked about the nature of the roots a couple lessons ago. Do you remember we talked about the number of solutions? And you could have like 2 solutions or 1 solution or no solutions. But then, I don't know if you remember this or not, but underneath my 2 solutions, I also said that was 2 distinct roots. And underneath my 1 solution, I said that that was 2 exact roots or 2 identical roots. And then underneath my no solution, I said it was 2 imaginary roots or 2 non-real roots. Those are the nature of the roots that we were talking about here, okay? So remember that a root is a solution to an equation. For us, we will be looking at the x-intercepts because one side of our equation will be equal to 0. So the next 3 questions are really the same as all the other examples I've given you so far. We just want to use the quadratic formula to determine the roots for the following. And we want to take a look at the graphs, and then we're just going to pull some information together with these 3, okay? But to do that, the first thing we have to do is actually figure them out using the quadratic form. Okay, so my first one is x squared plus 12x minus 8 equals 0. I'm going to go through these steps just a little bit quicker because I've kind of already gone step by step and shown you how to use the quadratic formula, okay? So I'm going to go right to plugging my numbers in. Then I want to figure out the 144 minus 4 times 1 times negative 8, which is 176. I can simplify 176 to be 4 root 11. And then I can look at all these and say, okay, I can take out a 2. I can reduce here. And that's going to end up being negative 6 plus or minus 2 root 11. Okay. Then when I solve this graphically, and it would be a good idea all through this to pause and you try it yourself, then compare pictures with me. But when I solve this graphically, I get a graph that looks like that. And really what I want you to see right now is that there are 2 roots, one here and one here. And so we would say 2 distinct or 2 different roots, okay? So here's the first example, and we'll come back to it in a minute, okay? The second example, I've got x squared minus 6x plus 9 equals 0. Again, we're using the quadratic formula. A is 1, B is negative 6, C is 9. I plug in all those numbers. I get what's underneath the square root as 1 number, which happens to be 0 here. The square root of 0 is 0, so I'm left with 6 over 2, which is just 3. Okay, go ahead and throw that in your graphing calculator. You should have gotten a picture that looks something like this. And this time I want you to notice there are not 2 distinct roots. There's only 1 solution here, but there are 2 roots. And what we say is they're identical roots. Okay, so there are 2 identical, sometimes you'll hear people say 2 exact roots, 2 identical roots. Okay, and then in the last example, we've got x squared minus 6x plus 11 equals 0. So my A value is 1, B value is negative 6, and C value is 11. Plug my numbers in. I get what's underneath the square root as 1 number. And then things fall apart because I see that I'm looking at the root of negative 8, and I can't do that. So at this stage, because I have a negative underneath the square root, I'm going to say there's no solution. When I go to look at a graph, please do so. When I go to look at a graph, I end up with a picture like this, and I can see there is no x-intercept, so it makes sense that there's no solution, okay? But there are still 2 roots. So what we say is they are 2 imaginary roots or no real roots, okay? So I want to take these 3 things and kind of put them side by side for a second so that we can take a look at what we see. So what I want you to notice is it's actually coming from the number underneath the square root. If this number underneath the square root is positive, then I get this plus or minus. And the plus or minus is what actually gives me the two different roots. Okay, one's adding, one's subtracting. Those are two different roots. Here, I ended up with the square root of 0. Well, the square root of 0 is 0. Whether I add 0 or subtract 0, it doesn't change the root, which means there's only one there. Okay, or the two identical roots, if you want to look at it that way. And then here we had the square root of a negative number, and that's where everything fell apart because I can't take the square root of a negative number, and that's where the no real roots comes from, or the two imaginary roots. Okay. All right, so let me take that ink off for you. The piece of the quadratic formula that tells us information about the nature of the roots is the thing underneath the square root, which was the b squared minus 4ac, and it's called the discriminant, okay? Therefore, to determine the nature of the roots algebraically without solving, all we need to look at is the value of the discriminant, which is b squared minus 4ac. Use the discriminant to determine the nature of the roots for the previous question. Well, I've kind of already walked you through that, but what I want you to notice here is for two distinct roots, the discriminant will be greater than 0. For two identical or equal roots, the discriminant is 0. And then for two imaginary roots, or no real roots, the discriminant is less than 0. Okay, so how do we use that? How do we put that into practice? I'll show you in a second. This just summarizes what I just said in a table. So if the discriminant is negative, there are two imaginary roots or no real roots. If the discriminant is 0, there are two identical or equal roots. And if the discriminant is positive, there are two distinct roots. Okay. All right, so algebraically determine the nature of the roots for the following equation without solving it. So I'm going to go right to my b squared minus 4ac. My b, a, and c are still gotten the same way, right? A is 2, b is 4, c is -10. But I'm going to just plug it into the discriminant this time. So I've got 4 squared minus 4 times 2 times -10. Okay, that gives me 96. I don't really care what the number is except to say, hey, my discriminant is positive. Because my discriminant is positive, that means I will have two distinct roots. Okay, so the discriminant is positive. This quadratic has two distinct roots. Okay, much easier than solving if we don't need to solve it. If the discriminant will get us to the answer we're seeking, go for it. Okay. Okay, determine k so that the equation x squared plus kx plus 16 equals 0 has equal roots. Well, if I want equal roots, that means I want my discriminant to equal 0. So I use the discriminant formula, but I set it equal to 0. I know that my a value was 1, my b value is k, and my c value is 16. So I plugged all that in. Here I get -4 times 1 times 16, so that'll be -64. I'll add 64 to both sides and then square root it, and k could be plus or minus 8. Okay, now just to show you, we said, or we're saying, if k is positive or -8, both of those will produce an equation where I only have one x-intercept. That's what two equal roots would be, right? So I've graphed both of these possibilities for you just to show you. So the red guy is with k being +8, okay? And you see that the vertex is on the x-axis, so there's only one solution. There are two identical roots there. And I use the -8 over here. This is same thing, right? Vertex is on the x-axis. There are two identical roots there, okay? So whether I use the +8 or the -8, it both works. They both work, okay? Okay, determine k so that the equation kx squared plus 4x plus 2 equals 0 has no real roots. Well, if I want no real roots, that means the discriminant has to be negative. So I use the discriminant and I say it has to be negative. It has to be less than 0. I know my my a value is k, my b value is 4, and my c value is 2, so I plug that in. 4 squared is 16. This is gonna give me negative 8k. 16 comes over here, so that'll be negative 16. And now you're just going to be careful with this. You have to divide by negative 8. When you're dividing an inequality by a negative number, the inequality flips. So this will become k is greater than 2. K is greater than 2. Okay? So that's where we are. You now know how to use the quadratic formula. You now know how to use the discriminant to determine the nature of the roots without having to solve for the roots themselves, okay? And you're feeling confident, you're feeling happy, you're feeling like you can take on the world, okay? So here's your homework. Tomorrow in your next lesson, we are gonna deal with applications. So it's another day to really focus on different types of word problems that we can have with quadratic equations. And then that will wrap up this unit. Okay, so as always, if you have any questions, you know where to find me. Please don't be a stranger. Connect with me, okay? We got this. You can do this, okay? Take care, guys.